Hi guys, this is Gopika here, and in this video I'll be discussing the property regarding the three parallel lines and the intercepts made by them or made by the transversals on them. Okay, the ratio of those intercepts made by the transversal on three parallel lines. Okay, so actually this theorem is a consequence of the BPT or the basic proportionality theorem that we learned, and the proof is also very simple. So let's see the statement and the proof. Okay. Yes. So before starting, let me choose. Okay. Theorem. Let's read the statement. The ratio of the intercepts made on a transversal by three parallel lines is equal to the ratio of the corresponding intercepts made on any other transversal by the same parallel lines. Okay. So if you have three parallel lines and two different transversals, then the intercepts formed are in the same ratio or in same proportion. Okay. So given line L, M and N are parallel lines and T1 and T2 are two different transversals. T1 intersects the lines at point A, B and C, and T2 intersects the lines at points P, Q, R. Okay, so here we need to do a simple construction for the proof, that is we join PC or we can join AR also. Only the triangles that we consider will change. As I said, we are going to use basic proportionality theorem. Obviously, we are first going to think about triangles, right? In triangle only we are applying those theorem. So we construct it like this, and in this construction at line the line M, D is the point at which this line intersects the line M. Okay. So to prove is AB upon BC is equal to PQ upon QR. Okay. So proof, first is draw segment PC which intersects line M at point D. Now consider the triangle AC. Let me highlight it for you. Alright. So we are considering this triangle ACP. Okay. If you see this triangle, BD is parallel to AP. So now here we can apply the BPT or basic proportionality theorem because we have a line which is parallel to one of the side of the triangle, that is AP is parallel to BD. Hence, the proportion of CD upon DP should be same as CB upon AP. Therefore, AB upon BC is equal to PD upon DC. This is basic proportionality theorem. Okay. If you have a line parallel to one of its sides of the triangle, then that line cuts the other two sides in same proportion. Okay, that is what basic proportionality theorem says. So AB upon BC is same as PD upon DC. Alright, now we consider the triangle at the right hand side. Here we go. Okay, so now we are talking about this triangle, that is triangle CPR. Here DQ is parallel to CR. Hence, DQ is cutting PC and PR at same proportion. Therefore, PD upon DC is equal to PQ upon QR. Again, we are applying basic proportionality theorem. Therefore, PD upon DC is same as PQ upon QR. This is our second point. Okay. Now, if you compare first and second points, then we have a common factor, that is PD upon DC. Hence, AB upon BC is equal to PQ upon QR. Okay, so from 1 and 2, we have AB upon BC is equal to PD upon DC is equal to PQ upon QR. Okay, but we just need this part. So we just write it, AB upon BC is same as PQ upon QR. And hence the proof is done. Okay, so first let me erase all. Okay, so let's revise the proof once again. Okay, so we have three parallel lines and two transversal T1 and T2, and then our aim is to prove AB upon BC is equal to PQ upon QR. Okay, so we do a simple construction by joining points P and C. Okay, segment PC we draw, and D is the point at which it intersects the line M. Okay, now we consider these two triangles. First we consider the left one, that is ACP. There we apply basic proportionality theorem since BD is parallel to AP. So by basic proportionality theorem, AB upon BC is same as PD upon DC. Now we consider the triangle CR or CPR, and there also DQ is parallel to CR. So by basic proportionality theorem, BD upon DC is same as PQ upon QR, and hence at the end we arrive at AB upon BC is same as PQ upon QR. Okay, because this ratio is equal to this and this is equal to this, hence these both ratios are equal. Okay, simple. Okay, so I'm done with this proof, and now we will discuss we will just revise the statements of those 4 theorems that we learned in last 4 videos. Okay, so first theorem was basic proportionality theorem that we just used to prove the property regarding the 3 parallel lines. In triangle ABC, if segment PQ is parallel to segment AC, so if you see the diagram, PQ is parallel to AC. Hence, by basic proportionality theorem, AP upon BP is equal to CQ upon BQ. Okay. Converse says, if you have a triangle with this ratio, then this line between ST has to be parallel with QR. Okay, with the third side. Okay, if ST cuts the 2 sides of a triangle in same ratio PS upon SQ is equal to PT upon TR, then ST has to be parallel to the third side. That is, ST has to be parallel to QR. This is what converse of basic proportionality theorem says. Okay, and in the textbook proof is not given, but I had discussed the proof in detail in my video. Okay, and the next theorem is the theorem regarding the angle bisector, theorem of bisector of an angle of a triangle. Okay, and this property also this triangle we proved in 2 ways. In one proof we used BPT, and in other I gave an alternate proof using the properties, two properties actually. One is regarding the angle bisector and one is regarding the ratios of areas of triangles, and converse also I had discussed. Okay, so let's revise the statement. If you have a triangle ABC and BD is bisector of angle B, then BD cuts AC in same proportion as of the other 2 sides. Okay, so AB upon BC is same as AD upon DC. Okay, simple. And then property of 3 parallel lines that we just discussed in this video itself, and their transversals. If line AX is parallel to line BY is parallel to line CZ, and line L and M are their transversal, then AB upon BC is same as XY upon YZ. So here when you write the ratio, you have to be very careful because the ratios are on the basis of the parallel lines. Okay, now the diagram actually is inverted over here. In the theorem we showed the parallel lines horizontally and then the transversals vertically. Here we have shown the parallel lines vertically and the transversals horizontally. So just just observe the diagram well and see where are the parallel lines, and accordingly choose the intercepts, and then the ratios will match. Okay, fine. So I'm done with this video, and in the next video I'll be discussing few solved examples in which we will use all this theorem and their statements actually. And thank you for listening to me. If you like the video, please share it with your friends, and please subscribe the Friendtor channel, and see you soon with the solved examples. Bye.